Okay, one more thing. I might as well do this today because otherwise you're gonna have. I'm gonna do it tomorrow. I might as well do it today. Just get it out of the way. So let's everybody close them up and take a look at this. This is something that I'm sure you covered, but it's always a little bit cryptic to students until they've done it a few times. So what about part A here? We want to know for what values of x does this function have horizontal tangent lines? What's my thinking in terms of the calculus? Where what's equal to 0?
X.
Or y.
Okay, the derivative equals 0, right? So horizontal tangent lines would be where the derivative equals 0, right? So that's true when f prime of x equals 0. So we have to differentiate. In part A, what's the derivative of the function with our new
7 minus 14.
7 plus 14 cosine x?
Yeah.
Okay. All right, so, and we want to set that equal to 0, right? For part A, we want to know where is f prime equal to 0, okay? So that's going to happen where 7 plus 14 cosine x equals 0. If I solve for cosine x, and this is what I want to focus on. When you're solving a trig equation like that, when we say a trig equation, it's an equation involving trig functions. So, you tell me, what am I going to do here? We'll talk about this. Say it again?
Let's solve it like you would.
Subtract 7.
Subtract 7, okay, divide by 14. So we're going to isolate the trig function first, right? So we know that cosine x is equal to negative 7/14, which is what? Negative 1/2, okay? All right, so that's the solution in terms of cosine x, but now what? Where is that true? Okay, or even better yet, unit circle.
Yeah.
Right, unit circle. So here's our unit circle step comes up again. So unit circle. We really need a day to just review the unit circle.
Yeah, we
So I showed you the hand trick, right?
do.
No.
Did I not show you guys the hand trick for you?
No.
Oh man, the hand trick is great. So if you want to know, if you guys want to know you ever want to know, let me scoot this over. This is all- Okay, so if you look at there are only some convenient points on the unit circle that we know, right? There's an infinite number of angles on the unit circle, but we only, we focus on the ones that have nice, convenient x and y coordinates. So what are the angles of those?
0.
Well, we know we got 0, and what's that one?
90.
90, but in radians?
Pi over 2.
Pi over 2, and then we've got
Pi over 4.
pi over 4 is right there, good.
Pi over 3.
Pi over 3 would be like right up there somewhere.
Pi over 6.
Pi over 6, okay, good. Right, so if the angles there would be, we said 0, pi over 6, pi over 4, pi over 3, and pi over 2. Okay, if we want to get the coordinates of the points on the unit circle there, and I'm going to put off an entire discussion of the unit circle. You guys pick a day here soon, and we really need to take a day and just kind of go through that.
Right.
I guarantee you'll feel better about things if we do. If you know the unit circle inside and out, man, you know a lot of trig right there, just that one thing. But there is an easy trick for coming up with the coordinates of all of those. You can make right triangles, and this is just kind of a mnemonic device, but it's handy. If you put your hand up like this, so your pinky is along the x-axis and your thumb is along the y-axis. Okay, this really works. So let's find the point here. Then I'm going to fold that finger in, and it's always going to work out to be the fingers that are above the folded finger are going to be, that's going to contribute to the x coordinate, and the fingers below contribute to the y coordinate. Okay, so we have to fill in these blanks. how many fingers are below?
Zero.
Zero. Okay, so the y coordinate is 0. What about the x coordinate? You're gonna take the square root of the number of fingers above divided by 2. What's the square, so how many are above? Square root of 4 is
2.
2. 2 divided by 2 is?
1.
There you go, you get 1. Okay, how about right here? How many fingers are below at that point?
1.
1. So the square root of 1 is
1.
over 2. How many fingers are above?
3.
So I get the square root of 3 over 2. Okay? How about right here?
2.
Square root of 2?
Doing math gang signs.
Yeah, it doesn't, yeah, math case, exactly.
We need to start doing these
Watch
in like
out.
high school photos and all that.
Yeah. And then up here, you see the trend. Up here, we're gonna get
1.
for our x,
Yeah, good.
and we're gonna get square root of 3 for our y, and then up here, we're just gonna get 1, 0, right?
That's
Square root
crazy.
of, right, you're gonna get 0,
So the
we're gonna get 0 to the left, and square root of 2 is, square root of 4 is 2, over 2 is 1. Right? So there's an easy way to.
Can you do it going the other ways?
We'll just
Go on.
change the sign.
Okay, so you mean like for the other quadrants?
Yeah.
Okay, if you know quadrant 1, you know every quadrant,
Yeah.
right? Because if I know, like you tell me right now, fill in the blanks for this one right here.
And the
Strong tires.
That's
every single
negative.
Square root.
Yeah, okay, so, right, it's gonna be, it's in line with this one, right? It's a
Yeah.
reflection of this point over the y-axis. So in quadrant 2, quadrant 1, x and y are positive. Quadrant 2, x is negative, y is positive. So all we're gonna do here is just make the x coordinate negative and the y coordinate positive, right? You see what I'm saying?
Yeah.
And if we fold it down to here, so the coordinates of this guy are gonna be negative radical 3 over 2, 1/2. If we fold it down to here, they're both negative, right? What about the angles? Angles are easy. If this is pi 6, then you know that this angle right here is also pi 6, so you just subtract that from pi to get the overall angle. So pi minus pi 6 is
Pi,
pi
pi.
6 pi. Right? This one's gonna be pi plus an additional pi 6. So that's gonna be 7 6 pi, right? So you can always, just so quickly, you can always come up with the unit circle. If you just know quadrant 1, right?
Yes.
Okay, so now let's get back to the matter at hand here. We've got, what happened over here? I don't know, it's weird.
Well, we have cosine x equals 1 negative.
I don't know how the 2 ended up over there. I'm not sure how that worked. But anyway, so we get cosine of x equals negative 1/2. Cosine is the x or the y coordinate,
X.
the x coordinate.
Yeah.
So where is the cosine,
Pi over
where is the x coordinate equal to negative
4,
1/2?
pi over 3.
4, 5.
That's gonna be the reflections of this point, isn't it?
Yeah.
Right, so we're gonna get points there. I just bad color. That's good color here. We'll go brown ones. So we're gonna get a point there that's gonna have an x coordinate of negative 1/2, and we're gonna get a point down there that's got an x coordinate of negative 1/2, right? Everybody agree?
Yes.
Okay, but here's the thing. We didn't limit our domain here. But how many times on the unit circle are you going to hit those 2 points?
Twice.
Quite.
On the first lap. But how
As
many
many
laps do you
times
take
as
on the
you
unit
want.
circle? An infinite number of laps, right?
Yeah.
Every time you make a lap of the unit circle, you're gonna hit those 2 points, right?
Mhm.
And so we gotta find a way here, a tricky way of saying, how am I gonna do that? I gotta find all those values, right? It's gonna be a long list if you have to write an infinite number of values though. So let's see if we can establish a trend here. What is this angle?
4 pi over
That's,
4,
it's 2 pi over 3.
2 pi over 3, isn't it? Right?
Yeah.
Everybody get that? Because, how do we know that? Because if this is pi thirds, then this one right here is also pi thirds. So we're gonna get pi minus pi thirds is 2/3 pi, right? So there's that angle. So one of the places, if we look at just lap 1 of the unit circle, this is gonna be true when x equals 2/3 pi. And what about down here?
4.
4/3 pi, okay?
And then it's
Okay,
plus
yeah.
2 pi.
So then, how are we gonna say all of those all of those possibilities. If I can go around the
Plus
unit circle an infinite
pi
number of times,
sine.
you tell me, so this is 2/3 pi. If I go around to my second lap, where am I? 2/3 pi plus, what's the?
Plus 2 pi.
Plus 2 pi, right?
Yeah.
Okay, so I can take an infinite number of loops around this, forwards or backwards. Each time I take a circuit around the unit circle, I'm adding a 2 pi to the original angle. Everybody agree?
Yes.
Yeah.
Okay, so we need to take this angle right here, and we need to supercharge it so it includes all of the possible angles. I've got to say all plus 2 pi times k. Call it k or call it n or something, where that's every possible integer, right? So we could say x equals 2/3 pi plus 2 times, or k times 2 pi,
I think you would find that.
where k is just an element of the set of integers, right? All the integers. We'll finish that up tomorrow. You get the idea, though?
Yeah.
I don't know, the current height of the